ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Hello students, now let us continue with the electron transport system. In electron transport system, where are we? We are in oxidative phosphorylation. We are in the discussion about oxidative phosphorylation. For the last class, mainly we discussed about the proton count and a number of ATPs for NADPH2 as well as we just calculated for FADPH2. So what is very important thing is, one NADPH2 contributes for 3 molecules of ATP, very important, and one FADPH2 contributes for 2 molecules of ATP. Okay. So here if you look at now for link reaction and Krebs cycle, we are just taking the count for link reaction and Krebs cycle. Now if you look at the calculation part, the energetics, we are mainly discussing about energetics. Now if you look at link reaction and Krebs cycle, in link reaction how many NADPH2 are produced? 2 NADPH2 are produced. In link reaction there is a production of 2 NADPH2. In Krebs cycle there is a production of 6 NADPH2 in Krebs cycle. Very important. Try to remember, we are not taking into count of calculation for glycolysis. We are not taking for glycolysis. Glycolysis just keep it aside because that happens in cytoplasm where each NADPH2 contributes 2 ATP. That we will discuss, right? We already have discussed, again we will discuss once again. But here we mainly discussing now link reaction and Krebs cycle together. Why we are taking link reaction and Krebs cycle together? Because these two happens in mitochondria. At the time of link reaction there is a production of 2 NADPH2. In Krebs cycle there is a production of 6 NADPH2. So what is the total number of NADPH2? Altogether there is 8 NADPH2 produced at the time of Krebs cycle, by the end of Krebs cycle. Right? Now what we said, each NADPH2 contributes 3 ATP and 1 FADPH2 contributes 2 ATP. So if you look at the calculation part here, now 8 NADPH2 is equal to 8 into 3 ATP, that is equivalent to 24 ATP molecules are produced from where? Are produced from NADPH2. Right? Altogether we are taking the count of what? 2 NADPH2 produced in link reaction, 6 NADPH2 produced in Krebs cycle. Total number of NADPH2 will become 8 NADPH2. Each NADPH2 contributes 3 ATP. So 8 into 3 ATP. So total number of ATP produced from NADPH2 by the end of Krebs cycle will be 24 ATP. Very important. Stepwise I am telling you because questions will make you a lot of confusion in ETS. Generally most of the times people cannot answer the question because the question itself they will not understand, because the questions will speak about stepwise calculation of number of protons and number of ATPs. Okay, so as based upon the question, based upon this you have to calculate. Suppose if they ask the question only about Krebs cycle, if they ask only about Krebs cycle, then how much? 6 into 3 ATP, then you will get only 18 ATP. Yes or no? So depending upon the question. So the question, if you understand properly, then you can answer the question properly. So you need to look for question meaning. Most of the times people always confuse here. So make sure that you concentrate. In the question, if they ask about number of ATPs produced from NADPH2 by the end of Krebs cycle means 18 ATP. In Krebs cycle means 18 ATP. Suppose if they ask the question in mitochondria by the end of Krebs cycle total number of ATPs produced from NADPH2, then you have to take the option as 24. Even though I say number of times, most of the time some people will take 18 if the question is given for that, they will take 18. If the question is given this, they will take 24. So make sure that you be clear with the clarity of the question. As per the question, you have to choose a option. That's why I am telling stepwise. Very clearly I am writing. Okay, that's why I wrote very clearly link reaction and Krebs cycle. Right? Now, similarly, if you talk about FADPH2. FADPH2 produced only in Krebs cycle. There is no FADPH2 in link reaction, so I am not writing there. So 2 FADPH2. So here 2 FADPH2 is equal to 2 into 2 ATP. Why? Because each FADPH2, one FADPH2 contributes to ATP. One FADPH2 contributes to ATP because altogether it includes 6 protons, right? And here it includes 10 protons. Even don't forget this count also. Right. So when you take 2 FADPH2, 2 into 2, altogether it contributes for how many ATPs? Here it contributes for 4 ATP. So 24 plus 4, so total number of ATPs will be 28 ATP. Yes or no? Right. And did you remember, suppose if you take only up to here, only up to Krebs cycle, if you take only up to Krebs cycle, then 2 into 2 ATP it will become 4 ATP. So here 18 plus 4, 22, and here there is 2 ATP produced during Krebs cycle. So 2 ATP if you add here 2 ATPs, so altogether it become 30 ATP produced by the end of Krebs cycle. By the end of Krebs cycle. By the end of Krebs cycle. In aerobic respiration, excluding what? Excluding what? Excluding glycolysis. Okay, this does not include glycolysis. So excluding glycolysis means without glycolysis, we are talking about only, we are discussing now what are the things which happens in mitochondria. So for all calculations we discussed how much energy is produced only in mitochondria. Krebs cycle happens in the cytoplasm. So this calculation excluding glycolysis, not without involving glycolysis in mitochondria. That means combination of link reaction and Krebs cycle produces altogether what is the total number of ATPs? Total number of ATPs produced are 30 ATP. Suppose if the question is without link reaction, if the question is about only Krebs cycle, if the question is about only Krebs cycle, so how much you will get? 18 plus 4 plus 2, 22 you will get total number of ATPs produced in Krebs cycle. So here total number of ATPs produced in Krebs cycle. If this is the question, answer is 24. Okay, if this is the question, then answer is 24. Very important question. If the question is about in mitochondria including link reaction and Krebs cycle, by the end of Krebs cycle, then 30 become the answer. So this is also an important question, 30 ATP. I hope you have the clarity. Most of the people, they'll confuse. If the question is given that, they will take this option 24. How many times we say also, be careful and try to understand. If the question is given this, they will take 30 ATP or they will take 28 ATP. So again I'm telling you, as per the question, without any confusion, you have to read the question. As per the question, you have to choose a correct option with correct number of ATP molecules. I hope this gives you clear clarity about choosing the correct option for the question. in terms of number of ATPs, right. So, look at here, again I will tell you, link each NADP, this is very important calculation which you have to keep it in your mind. So, for your sake I will repeat again, guys, concentrate. This is the story of mitochondria. Here I am not talking about glycolysis, because glycolysis occurs in cytoplasm. I am not adding about NADPH2 of glycolysis, right. So, here each NADPH2 in mitochondria, this calculation is for mitochondria. In mitochondria, what is happening is electron transport system, that is oxidative phosphorylation. So, here each NADPH2, one NADPH2 contributes for 3 ATP because we get the count of 10 protons. One FADPH2 contributes 2 ATP because we get the count for 6 protons. Now, in mitochondria, which two reactions takes place? Link reaction and Krebs cycle. Now, this link reaction and Krebs cycle, from link reaction there is a contribution of 2 NADPH2. From Krebs cycle there is a production of 6 NADPH2. 6 plus 2, 8 NADPH2 are produced. Now, here 8 into each NADPH2 3 ATP. So, 8 into 3 24 ATP produced at the end of Krebs cycle. Similarly, in Krebs cycle 2 FADPH2 is produced, 2 into 2 ATP, it produced 4 molecules of ATP. In Krebs cycle there is already 2 ATPs produced, altogether it becomes 30 ATP. So, this is what is, how much is produced here? 30 ATP, very important. Now, this is mitochondria. Let us talk about glycolysis. Glycolysis happens where? Glycolysis happens in the cytoplasm. You know that how many ATP are produced in glycolysis? Number of ATPs produced. How many are produced? There is 4 ATP. Right? But in that, number of ATPs consumed, right, number of ATPs consumed at the time of glycolysis. How many ATP consumed? 2 ATP is consumed. So, 4 minus 2, you will get net gain how much? 2 ATP. 2 ATP is nothing but net gain. Net gain is 2 ATP. You remember we discussed this. I think you have full clarity in your mind. I hope you guys are following carefully, right? In glycolysis, it happens in cytoplasm where number of ATPs produced are 4 and number of ATPs consumed in that are 2. So, net gain is 2 ATP. Still we have NADPH2 contribution is there, no? So, from NADPH2, how many NADPH2 are produced? 2 NADPH2 is produced. But here the reaction is happening in the cytoplasm. Each NADPH2 contributes for 2 ATP. So, here you can remember each NADPH contributes for 2 ATP, not 3 ATP. This is a very important difference. Whereas here each NADPH2 contributes for 3 ATP because this reaction is happening in mitochondria. Very important difference. In mitochondria, each NADPH2 contributes for 3 ATP. Whereas in cytoplasm, because glycolysis happens in the cytoplasm, each NADPH2 contributes for 2 ATP. Very important. I hope you got it. Very important. Always most of the people will confuse here. Each NADPH2 contributes for 2 ATP because it happens in cytoplasm and that's what you have to take count in glycolysis. That means 2 NADPH2 means 2 into 2 ATP altogether produces 4 ATP. So, total number of ATPs will be 6 ATP. That is from glycolysis. So, glycolysis total number of ATPs, from glycolysis is 6. Okay, this is number 1. Including link reaction and Krebs cycle, total number of ATPs produced is 30. So, what you will write? 6 ATP from step number 1, 30 ATP from step number 2. So total number of ATPs in aerobic respiration is 36 ATP. Don't worry, we will write again balance sheet, total balance sheet for the count of 36 ATP, but you have to remember that means whenever you get the question that in aerobic respiration, by the end of aerobic respiration, total number of ATPs produced will be 36. 36 is very, very important. Out of this 6 ATP we get it from glycolysis and 30 ATP we get it from the link reaction and Krebs cycle. Total count will be 36 ATP. So don't worry, again we will write a balance sheet for ATP, total number of ATP. At that time you will get the clarity of the stepwise and where ATP is produced, from what to what conversion, each and everything you have to remember very, very carefully, right? Let us continue further here. Now let us make a clear difference between the two important processes. One is called as photophosphorylation and other one is called as oxidative phosphorylation. One is called as photophosphorylation, another one is called oxidative phosphorylation. Now let us make clear difference between photophosphorylation and oxidative phosphorylation. Now if you look at in this case, photophosphorylation, it happens in which process? It happens in photosynthesis, right? Where in photosynthesis? At the time of light reaction. Where in light reaction? Here it happens in the chloroplast. It happens in the chloroplast. Photophosphorylation happens at the time of photosynthesis in the chloroplast. Coming to oxidative phosphorylation, it happens in respiration. Where in respiration? It happens in case of mitochondria. Oxidative phosphorylation happens in mitochondria. Now where exactly in chloroplast here? So here this happens in occurs in thylakoid membrane, that is in lumen of thylakoid. It occurs in the thylakoid membrane of chloroplast. Where oxidative phosphorylation occurs? Now this oxidative phosphorylation occurs in inner mitochondrial membrane. What is this IIM? Inner mitochondrial membrane. See, in both cases membrane is there, right? So very clear differences you can make out. So this happens in the presence of light. Here the source of energy is from light. Let us write first the definition. What is the definition here? So you all know it very well. Phosphorylation always speaks about ATP synthesis. In the presence of light, it's called photophosphorylation. So what is the definition we can write? It is a process of synthesis of ATP, right, during a non-cyclic electron transport system or during cyclic electron transport system. It's called photophosphorylation. So here this is a process of ATP synthesis during non-cyclic electron transport system or cyclic electron transport system. Now coming to oxidative, this is nothing but we can write synthesis of ATP, right, during electron transport system. Now here what is the source of energy? Here sunlight or itself is called radiant energy act as the source. That means the entire process occurs in the presence of sunlight or radiant energy act as the source. Sunlight is the source of energy. So here in the presence of the process takes place in the presence of sunlight. And what is the source for oxidative here? So here the source is nothing but oxidation of food materials. What is the source? The oxidation of food material act as the source of energy. Which act as source of energy in respiration? The breakdown of the food at the time of respiration produces energy. That energy NADPH2 FADPH2 enters into ETS. In ETS it produces ATP, right. So here apart from this, so you know photophosphorylation, light derived process, oxidative phosphorylation, here oxidation of food materials takes place, right. So here altogether how many complexes are there in electron transport system? In non-cyclic and cyclic there are mobile electron carriers are there. Which are mobile electron carriers? So in photophosphorylation mobile electron carriers are there. Which are they? Ubiquinone, cytochrome C, right, cytochrome B and plastocyanin. So these act as mobile electron carriers, whereas in oxidative transfer here it includes two mobile electron carriers. Which are two mobile electron carriers? Which are they? One is ubiquinone, other one is cytochrome C. Right. So there are so many enzymatic complexes are there. Many enzymes plays a very vital role. ATP synthetase and other enzymes plays very vital role. Here what happens in case of this, in the lumen of thylakoid, what occurs is with the help of ATP synthesis, ATP synthetase, there is a release of ATP, but here what happens? Here there is a dissociation of water. That means photolysis of water takes place. That means here photolysis of water takes place where in the lumen of thylakoid with the help of ATP synthetase at the time of ATP synthesis. Whereas here where this will happen? This is happen in inner mitochondrial membrane. Inner mitochondrial membrane, what happens here? There is a formation of water. Here there is a dissociation of water, but here there is a formation of water. In inner mitochondrial membrane, altogether there are 5 enzyme complexes are involved. But formation of water occurs with complex number 4 at the time of ATP synthesis. So these are the very important differences here between photophosphorylation and oxidative phosphorylation. So here photophosphorylation occurs at the time of photosynthesis, oxidative phosphorylation occurs in respiration. Which cell organelle involved means chloroplast here. Using light there is a synthesis of ATP in chloroplast, it's called photophosphorylation. In respiration in mitochondria, breakdown of the food involved in ATP synthesis that happens in mitochondria. mitochondria. Now this occurs in thylakoid membrane, lumen, whereas this occurs in inner mitochondrial membrane. So synthesis of ATP during non-cyclic ETS or cyclic ETS is actual process what happens in photophosphorylation. Here synthesis of ATP occurs during ETS in mitochondria. Very important differences. In the presence of sunlight, radiant energy act as what? Source of energy. Sunlight is a source of energy. Here oxidation of food materials will act as source of energy. Mobile electron carriers are nothing but ubiquinone, cytochrome C, of course plastoquinone, even you can write plastoquinone, mobile electron carriers, right, cytochrome C, cytochrome B and cytochrome B6F and plastocyanin. This all act as what? Mobile electron carriers. But in case of this, only two mobile electron carriers are there, ubiquinone and cytochrome C. Now here in the lumen of thylakoid, ATP synthetase is an enzyme, plays a vital role, and there what occurs is nothing but dissociation of water or breakdown of water. Whereas here in inner mitochondrial membrane, 5 enzymatic complexes participate. With the complex number 4, there is a formation of water. Water is formed here, water is broken here. So these are the very important differences between photophosphorylation and oxidative phosphorylation. Let us continue further. So now we studied very clearly for photophosphorylation and oxidative phosphorylation. Now let us write a balance sheet for ATP. Balance sheet for ATP. Let us clearly write the balance sheet for ATP. Now in this each and every step where ATP is produced, where ATP is consumed, we need to write very clearly. So let us start writing. This is also important. Now total aerobic respiration, now we are going to put together at one place. Aerobic respiration has 4 steps, all of you know: glycolysis, link reaction, Krebs cycle as well as ETS. Now let us start with first one, that is glycolysis. Very first one is what? Glycolysis. So let us write the steps also, where the formation occurs. Right, in glycolysis if you look at, now which are the places where ATP is produced in conversion of G3P, glyceraldehyde 3-phosphate 2, or you can take 1,3-biphosphoglyceraldehyde. Okay, let us take NADPH2. Let us take the count for NADPH2. G3P through 1,3-biphosphoglyceric acid. Right, G3P to 1,3-biphosphoglyceric acid. How much energy is produced? 2 NADPH2 is produced. You know, glycolysis happens in the cytoplasm. So what do we say here? Each NADPH2 will contribute for, so here 1 NADPH contributes for 2 ATP. 1 NADPH2 contributes for 2 ATP. 2 into 2 ATP. So here there is a generation of 4 ATP. Right? Now this is from NADPH2, that is glyceraldehyde 3-phosphate to 1,3-biphosphoglyceric acid. Sometimes they will ask you what is an enzyme in the production of NADPH2 at the type of glycolysis. Not only the substrate and product, even you have to remember the enzyme. Right? Now let us continue further. Now you know the step where like we can take 1,3-biphosphogliceraldehyde to 3-phosphoglyceraldehyde. Right? So how many ATPs are there? That is called substrate level phosphorylation 1. What is it called? Substrate level phosphorylation 1. How much ATP is produced? So altogether there is 2 ATP is produced. Right? Similarly, the conversions from where to where, PEP to pyruvic acid. Conversion from P, all steps you have to remember, very important. Phosphoenol pyruvate to conversion into pyruvic acid, that itself we call as substrate level phosphorylation number 2, very important. There is a synthesis of 2 molecules of ATP. Right, NADPH2, this 4 ATP you keep it aside. Now all together it becomes how much? 4 ATP. So very important. Now ATP is consumed. Here these all are nothing but what? Number of ATPs produced. Right, number of ATPs produced. Now number of ATPs consumed. How many and where? In glycolysis, right? So number of ATPs consumed here, if you take the conversion from glucose to glucose 6-phosphate, conversion, very beginning of glycolysis, the time of conversion of glucose to glucose 6-phosphate, phosphorus attached to 6th carbon, coming from where? Coming from, there is a consumption of ATP, so there is 1 ATP is utilized. 1 ATP is consumed. 1 ATP is consumed. So arrow mark I am writing towards this side. 1 ATP is consumed. Right? Now fructose 6-phosphate 2. What is that? Fructose 6-phosphate 2. Fructose 1,6-biphosphate. During this conversion, there is one more ATP is consumed. There is one more ATP is consumed. So here conversion from glucose to glucose 6-phosphate, 1 ATP is consumed. Fructose 6-phosphate to fructose 1,6-biphosphate, one more ATP is consumed. So total number of ATPs consumed are nothing but 2. Right? So number of ATPs consumed are 2. Right? 4 are produced, 2 are consumed. So what is the net gain here? Net gain will be 2. 4 minus 2, you will get 2. So 2 is nothing but what? Net gain. Now this 2 ATP we are going to join with 4 ATP of NADPH2. Altogether total number of ATPs produced are nothing but, by glycolysis, total amount of ATPs produced are will be 6 ATP. So what do I write now? So here total number of ATPs produced in glycolysis. What is the total number of ATPs produced in glycolysis? This may be a possibility of getting the question. So you will get 6 ATP. So 6 ATP step number 1. I hope you all got it, right? So this is NADPH2, we got 4 ATP kept aside. The number of ATPs produced are 2 plus 2, 4. So we are adding produced are 4. Then number of ATPs consumed are 2, 1 plus 1, 2. 4 minus 2 is 2, 2 is the net gain. So 2 ATPs are produced. So 4 plus 2 will be 6. So altogether total number of ATPs produced in glycolysis will be 6 ATP. That is step number 1. Okay. So let us write step number 1. Now let us go with link reaction. So let us go with next one is link reaction. Step number 2 is a link reaction. Now in link reaction, you know that link reaction happens in mitochondria and happens in mitochondria. Here glycolysis happens in cytoplasm, that is why 1 NADPH2 we have taken contribution of 2. In link reaction there is a production of 2 NADPH2 and here 1 NADPH2 contribute for 3 ATP. Each one contribute for 3 ATP. So 2 NADPH2 meaning 2 into 3 ATP. So altogether there is a production of 6 ATP. So that is step number 2. That is step number 2. right? Step number 1, glycolysis, 6 ATP. Step number 2, link reaction, where there is a production of 2 NADPH2, but each NADPH2 contributes 3 ATP because it's happening in mitochondria, whereas 1 NADPH2 contributes for 2 ATP because this happens in cytoplasm. That is a very important difference, very important difference. So 2 NADPH2 means 2 into 3 ATP, it contributes 6 ATP. That is step number 2, right? Now let's go with Krebs cycle. Now if you take Krebs cycle, also happens in mitochondria. From here everything happens in mitochondria. Now there is a substrate level phosphorylation number 3, right? Very important, where conversion of succinyl CoA to succinic acid. There is a release of 2 molecules of ATP. Right, that is very important. Substrate level phosphorylation 1, substrate level phosphorylation 2 happens at the time of glycolysis, but substrate level phosphorylation 3 happens at the time of Krebs cycle, where conversion from succinyl CoA to succinic acid to ATP, right? Then after this, then we can take isocitric acid to oxalosuccinic acid, right? So there is a 2 NADPH2 produced, that is 2 into 3 ATP. So altogether it produces 6 ATP. That is conversion from where to where? Isocitric acid to oxalosuccinic acid. How many ATPs? 2 NADPH2 are produced. Right, then leave the oxalosuccinic acid to isocitric acid to oxalosuccinic acid to alpha ketoglutaric acid, right? So let us take alpha ketoglutaric acid converts to succinyl CoA. At the conversion from alpha ketoglutaric acid to succinyl CoA, there is again 2 NADPH2 is produced. Now this contributes 2 into 3 ATP, that is there is a formation of 6 molecules of ATP. And the next step, malic acid to oxaloacetic acid, last step of Krebs cycle, that also generates 2 molecules of NADPH2, that means 2 into 3 ATP, that contributes 6 molecules of ATP, right? Then next is what? FADPH2, right? So FADPH2 from where to where? So here if you take FADPH2, generates from where to where? Succinic acid to fumaric acid. This generates fumaric acid. Now this generates how many FADPH2? 2 FADPH2, that means here 2 into 2 ATP. Why? Because each FADPH2 contributes for 2 ATP. As 1 FADPH2 contributes for 2 ATP here, so 2 FADPH2 meaning 2 into 2 ATP is generates 4 molecules of ATP. So number of ATPs are 2 which are produced. NADPH2 contributes for 3 6 are 18 ATP, and then 4 ATP from FADPH2. Up to Krebs cycle how many it will become? 18, 19, 20, 24 ATP. So this is Krebs cycle. Step number 3. This is step number 3. Step 1 is 6 ATP. Step 2 link reaction is 6 ATP. Step 3 glycolysis is nothing but 24 ATP. So after you write the total balance sheet of ATP, so what you will write now? Now take step 1, step 2, step 3, right? So now in the total aerobic respiration, what do we do now? Now we take step 1. Step 1 is what? Glycolysis. Glycolysis how much ATP? 6 ATP, right? And step 2. Step 2 is what? Link reaction. How much ATP there? 6 ATP. And step 3. Step 3 is what? Krebs cycle. How much ATP? 24 ATP. Now if you add all together, so what you will get? How much you will get? 36 ATP. So here total number of ATPs produced during aerobic respiration is 36 ATPs. So you can take aerobic respiration contributes 36 ATP. 36 is very important. What are the total number of ATPs produced here? So 2 is a net gain, 2 ATP from glycolysis, right, and 2 ATP from Krebs cycle, number of ATPs, right, plus altogether 10 NADPH2. 10 is coming from where? 2 NADPH2 from glycolysis, 2 NADPH2 from glycolysis, and 8 NADPH2 from Krebs cycle. 8 NADPH2 link plus Krebs cycle, plus and 2 FADPH2. Okay, so this is the count you have to remember. 10 NADPH2, 2 FADPH2, 2 ATP from glycolysis, directly net gain, not including NADPH2, 2 ATP from Krebs cycle. Altogether if you join this total all, 36 ATP you will get. 2 ATP from glycolysis, 2 ATP from Krebs cycle will come under substrate level phosphorylation 1, 2, and here Krebs cycle substrate level phosphorylation number 3. Very important, right? Out of 10 NADPH2, 2 NADPH2 are from glycolysis, 8 NADPH2 are from link reaction and Krebs cycle. So in the textbook it will be given 10 NADPH2. This is what you have to remember the count, and 2 FADPH2 from Krebs cycle. Altogether total amount of ATP produced during aerobic respiration is 36 ATP. In that each and every step of where NADPH2 produced, where ATP is produced, each and every step, substrate, product, enzyme you have to remember. You have to remember all the steps of aerobic respiration.
ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన ఎన్ఎస్ఆర్ ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ ఎన్ఎస్ఆర్ ఇంపల్స్.